Go ahead.
Okay, so my project is rapid analysis with AI. Before that, I'm going to tell you a bit about my background. So I'm Andrew Kamal. I do computer and electrical engineering, and I'm a cloud data analyst at a small firm called Kia Risk. It's a marketing firm, so what I do for them is they have a bunch of analytical data from past customers, usually people who use e-commerce or things like that a lot. And I end up data mining essentially all that analytics data into dashboards for them, so they end up finding what works and what doesn't, and able to optimize their spending budget. But that's a bit about my background. In my free time, I'm a hackathon and startup junkie. So the project I'm entering is for the 2017 GIF Ab Nelson Challenge, which is basically a challenge where you're liberating species from open data repositories for reuse in the scientific community. And my project, essentially what I have is all these repositories from open source ecological repositories for different species. And what I want to do is I want to mine that data, and I use predictive analysis to find out different correlations, different averages, and things like that using AI and RapidMiner Studio's platform. So this makes it easier for you to obviously share that information. So an example of what I have right here is Panthera data of different genomic species. So we have order, family, classification. So this is basically the Darwin core classification for different animal species. And you have this dashboard in RapidMiner's own interface. And basically the predictive analysis extension, you can look at the different classification of species, and you can see things such as activity cycles, the average body mass, their diet. You can even see their sexual maturity age and their activity cycles, which I have no idea how to get that data, but that's not my problem. And then another thing is you can also visualize rain levels using another ecological repository. So this shows the last 46 years, and also different density levels and things like that. I'll get more into a demo later on. So what we have is the Darwin core metadata graph. So this is a scatter plot, and this shows the temperature mean for the activity cycle. And what we have here is you can look at all those classifications, and you can actually see the averages and the maximum and minimum for thousands upon thousands of species. And using rapid analysis and AI with data mining, you can use programs like R and Zplot to look up up to 800 million different species from open source repositories and be able to come up with some sort of correlation or averages in different species in a few minutes. So why data analysis and AI go hand in hand? So artificial intelligence, using it for data regression and data analysis or predictive analysis in the future is where the future needs to be heading for AI. You can do stuff like financial predictions. You can be able to measure cancer genomic case studies in few seconds. You can be able to predict upward trends. You can be able to coincide with world events, or you can look at stuff like the Stratus project or the Google Lunar project and be able to evaluate cosmological data. Okay, yeah, it's good now. Okay, sorry about that monstrosity. But here you can see stuff like the entire adult body weight, and you can look through all these data repositories for different genomical classifications using a predictive analysis API, and then for stuff such as the rain levels demo, what you'd have here is you can be able to look at this scatter chart, or you can, if you use SOM or density, you can find out different rain densities of what you end up measuring. Oh, here we go. So you can do stuff such as heat mapping past past data from open repositories and end up seeing correlations. Now, the reason people would want to see stuff like brain densities or they'd want to see the sexual activity in different animals or be able to classify all these species and look at activity cycles is stuff like finding out which ones could be in the extinction list, evaluate different climate trends, and things like that. So that's my demo. Do you have any questions?
This looks pretty similar to like Tableau or something. Is that kind of what it's like?
Well, Rapid Miner Studio, the difference between it and Tableau is you can integrate R and Zplot and more advanced modules. With Tableau, you can do lots of stuff like that, but Tableau is not as developer or open source friendly. Like there's a Hadoop extension for Rapid Miner Studio, and it's mainly used by data scientists, while Tableau is more towards analytical marketing.
Firstly, I want to add that this is all very impressive. Secondly, I have a question actually. With all of this data, have you personally made any use of any of that data? Like, what kind of like special analytics have you done with that, if any?
Well, right now for the ecological data, this is for a hackathon state, so it's in its early stage. But in the past, I looked at different analytics from companies like one company who sold drones for like 5 or 6 years, and they were doing different marketing things. And you have the Google Analytics dashboard, the Hootsuite dashboard, and all those. And basically, it's like hundreds of thousands of different columns and things like that. And you can see the average cost per click, conversion rates. Now, if you tried going through Google or Hootspot and seeing the averages for that, it would take forever. What I do is I end up exporting the data directly to a data mining program like that, and then integrate usually an R or Zplot script, and I end up spawning the averages in a few minutes. Obviously, it's like a few hours of dev work to set that up, and I can tell them, hey, this marketing method has been wasting your money, shut that down immediately. This marketing method is good, complete it. And then other people would use stuff for predictive analysis to, especially with a cancer genomics example, they'd be able to predict different cellular trends, like different vaccines and rDNA and things like that. I don't know much about the medical aspects of it, but I know it's very useful in the medical industry to be able to have predictive analysis for different patient data. Now, with PMI and private healthcare information, they use ones that are in the public domain. So those people are organ donors or dead in the past, obviously.
Awesome.
Anything else?
Thank you.